Starlab Space, the consortium designing and building the Starlab commercial space station, is said to be the top research outpost in orbit, overtaking the soon-to-be deorbited International Space Station. When launched in 2029, it will have similar research capability to the ISS, despite having less than half the internal volume. We'll go over the updates and news about Starlab over the last year, their partnerships, service agreements, and potential customers. The consortium, led by US company Voyager Technologies, previously known as Voyager Space, includes European, Japanese, and Canadian companies in a joint venture that's been making steady progress towards a launch before the end of the decade. Given the large diameter of the space station at nearly 8 meters, it can only be lifted into orbit by the as yet non-operational Starship. Although, as a fallback, the upgraded New Glenn would also be able to lift it with its expanded 8.7 meter payload fairing. In March of 2025, the station passed its PDR, or Preliminary Design Review, in collaboration with NASA. In the summer of 2025, Starlab began building a full-scale mock-up of the station to be located at NASA Johnson Space Center. This will be used for interior design, crew training, procedure development, hardware checks, and in-flight issue resolution. In September 2025, Voyager selected Vivace to handle manufacturing of Starlab components. In December 2025, only a month ago, Starlab passed its critical design review, validating the station is ready for crewed operations. This is a major milestone, meaning that flight hardware can now be manufactured. The full-scale mock-up was delivered to NASA at the Johnson Space Center in Houston. Transatlantic arrangement. Key strength or key weakness. The geopolitical environment cannot be ignored. Given the frosty relationship between the US and Europe, and Canada for that matter, this adds risk to the project. For instance, only a few days ago, Canada was threatened with 100% tariffs on all goods and services into the US. Given that MDA Space, a key partner in the consortium, is a Canadian company, does that mean the price of their robotic arm, when imported into the US for final assembly, could double in price? Let's be clear, using the expertise in Europe, Canada, and Japan strengthens the Starlab consortium. These non-US companies have expertise in all areas of spaceflight and will reduce timelines and technical risks associated with building a large, complex space station. International partnerships are beneficial for financing the space station, which involves high capital expenditure. In addition, a multinational partnership broadens the customer base, with government agencies and private companies more likely to select Starlab if their country is actively involved in construction and operation of the space station. In a way, Starlab is mirroring the successful construction and operation of the International Space Station, which was at risk of cancellation several times, but due in part to international agreements, continues to operate today. Key partners. Let's look at the key partners in turning the vision of a large orbiting commercial space station into reality. The prime contractor is Voyager Space from the US. It's the majority owner and provides overall management of the project. It has expertise in mission control, payload services, hosted payloads, and crew health. Airbus, a major aerospace company in Europe, handles the technical design, engineering, and manufacturing oversight of the habitat, although Vivace was selected in September 2025 to manufacture the primary structure, that is, the outer pressure shell, with Airbus undertaking habitat engineering and final integration. Airbus has spaceflight expertise, having built the Columbus module on the ISS, the automated transfer vehicle, and manufactures the Orion service module for Artemis missions. Mitsubishi from Japan is a major corporation, having been involved in the H2 transfer vehicle and the Japanese experiment module on the ISS. MDA Space from Canada builds robotic arms, providing the Canada arm on the Space Shuttle and the Canada Arm 2 on the International Space Station. Palantir from the US provides exclusive software and AI solutions for Starlab, enabling digital twins, predictive maintenance, mission planning, and real-time operations. Palantir's software is expected to play a central role in the high-throughput Starlab is targeting for research. And Space Application Services, or SAS for short, in Belgium, a recently added equity partner, has experience developing and operating with launch vehicles, robotics, and control centers. Service partners, cargo missions, and others. On the service side, Starlab has a number of agreements with companies to provide services to the space station. For instance, Northrop Grumman, the owner of the Cygnus cargo vehicle, has a 5-year agreement with Starlab to support resupply of the space station, including cargo, supplies, and handling waste removal. Hilton is providing services with designer crew suites, communal space, hospitality, and co-marketing for tourism. The Ohio State University in the US is helping with academic research, plant science, biology, and business development. Potential customers. Turning to potential customers, Starlab has an agreement with Redwire, a major customer for research on the ISS, to be a channel partner. This gives the company reserved payload capacity on Starlab, plus the ability to provide advanced hardware platforms to the station, providing research opportunities to its existing global customer base. In addition, Mitsubishi has reserved and pre-purchased payload capacity on board Starlab. They intend to work on drug discovery, nanomedicine, materials, and semiconductor research and manufacturing. Although not commercial customers, Starlab has also received $217 million from NASA through the CLD Phase 1 awards and $15 million from the Texas Space Commission. Starlab Space Station, what we know. Starlab will support future tech development, drug discovery, pharmaceutical production, silicon wafer manufacturing, Earth observation, and more. It's designed for high-tempo operations, not bespoke missions. Starlab believes the space economy only works when there is an operational destination. One crucial aspect to understand is that launch is no longer the bottleneck. With commercial launch options increasing every year, the new constraint is orbital infrastructure. Space operations are becoming destination and product driven. With no space station, commercial research and development pipelines stall. Microgravity manufacturing cannot scale beyond prototypes. Starlab is big enough to solve this problem. It's designed for continuous human presence with a large internal volume, robotic arm, and payload lockers to support many customers at the same time. Deployed into orbit on board the Starship vehicle, Starlab provides advanced capabilities across 7 decks, supporting crew training, research, and commercial development missions all at the same time. Starlab European User Conference in October 2025. A slide deck from this conference was uploaded to the X platform, which gives us detailed information about the station. Here's what we learned. It's explicitly stated that the pressurized volume is 387 cubic meters in the key internal features slide, slightly lower than the 400 to 450 range that was stated previously. The floor space is 145 square meters or 1,560 feet, which supports a multi-deck configuration. The deck layout is Deck 0, Subsystems and Power Distribution. This is the base floor on the station. Deck 1, System Bays, Exercise Area, Lavatory and Hygiene. Deck 2, Payload Bays and Orbital Laboratory. Deck 3, Crew Quarters, Galley, Earth Viewing and Living Areas, plus 2 internal payload platforms. Decks 4 to 6, primarily stowage, with additional payload platforms on Deck 5. The station is 17 meters in height, with a diameter of 7.7 to 8 meters. In terms of payload capacity, a key metric for commercial space stations, there are 13 internal payload platforms, each supporting 10 mid-deck locker equivalent units. That's a total of 130 units. 2 external platforms for a total of 18 external payloads serviced by the MDA robotic arm. An average of 12 kilowatts of power with a peak of 16 kilowatts for payloads plus thermal management. This reinforces the point that Starlab is a research powerhouse with an enormous research and development capability. In addition, it has dedicated labs, glove boxes, workbenches, cold storage, and flexible leasing models. In terms of Starlab's orbit, it will fly at an altitude of 500 kilometers at an inclination of 45 degrees circular orbit. That's 100 kilometers higher than the International Space Station typically orbits, reducing atmospheric drag, resulting in fewer reboosts needed. The station's orbital inclination is 6 degrees less than ISS. It's not known why this angle was chosen. It's worth noting that the orbital debris risk is higher at 500 km than at 400 km altitude of the ISS. The dwell time for orbital debris at 500 km is longer than lower altitudes, increasing the probability of collisions. Radiation levels are also higher for Starlab than for ISS. 3 docking ports are included, with the station supporting 4 crew on a continuous basis, with 8 crew during turnover and overlaps. The slides list some competitive advantages, such as single launch on a Starship vehicle to avoid complexity with space station assembly. For instance, Axiom Station is assembled over many years. The competition. A number of other companies are working on designs for commercial space stations to replace the International Space Station. NASA will likely pick at least 2 designs or more for the Phase 2 funding award due later this year. With a full and open competition, any company or consortium can bid. Vast Space, which was due to launch their small Haven 1 station this year, has now delayed launch until 2027. This is the smallest of the space stations and will likely be aimed at tourists and short-stay visits for crew training, with only 10 internal payload slots available. Axiom Space is targeting late 2020s to early 2030s for an independent space station, although their first module will be attached to the ISS no earlier than 2028. Orbital Reef from Blue Origin has been very quiet for the last 2 years, so I really can't comment on their progress. My assessment is Orbital Reef is not a priority for Blue Origin. It's possible new contenders will bid for the Phase 2 award. We know from Phase 1 that SpaceX proposed their Starship vehicle. Perhaps they will bid again. Then there is Max Space, who recently proposed their Thunderbird inflatable space station design. It seems likely they will bid for a Phase 2 award. Sierra Space has developed inflatable habitats and could bid one of their life habitats. They're part of the Orbital Reef project, but that doesn't stop them bidding separately as well. They've developed the Dream Chaser vehicle, which could service their life habitat with cargo initially and later on crew. Other companies such as Lockheed Martin have developed inflatable habitats, but haven't shown any interest in bidding. They were originally part of the Starlab consortium and offered their inflatable module, but were replaced by Airbus, which went with a traditional metal module design. Final thoughts. Many questions remain about NASA's approach to commercial space stations. How many designs will be funded in Phase 2? How much funding will the winners receive? How many missions per year does NASA plan to these space stations? Then, of course, we need to think about how many private astronaut missions, tourist or research missions will be scheduled. It's difficult to know if commercial space stations are viable yet. The demand is hard to gauge. What do you think of the Starlab space station? Is it the front runner in the competition for NASA's CLD awards? Do you think it will be successful? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Space News Live is on Saturday evening or Sunday morning, depending where you watch from. The live stream is a great way for you to share your thoughts and opinions on the videos I posted this week, or on any space topic in general. I highlight the most thought-provoking comments on videos I received, along with previews of upcoming content. If you got the time, please tune in and say hi. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry, with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.